Good morning. I'm Mr. Cartenuto, and this is day one of geometry. What is geometry? Geometry is the math of shapes. I could give you a more formal definition, but this is an awesome definition if you want to understand whether you're looking at geometry or not. Math of shapes. What then is algebra? You took algebra last year. What is algebra? Now, I don't want a technical definition. I want a working definition that works exceptionally well for this class, and here you go. Algebra is the math of equations with variables. You need both ingredients, equations with variables. Here, you tell me 7 equals 7. Is this algebra? No, it's not. It is an equation. How do you know it's an equation? It's got an equal sign and two sides. But does it have any variables? No, so not algebra. How about this? 7x equals 7x. Algebra? Yes, it's an equation with variables. How many variables? 1. It's got the variable x in it. All right. Geometry is an interesting class. I don't know what you've heard about it, but I can tell you something. When I tell people what I do, I teach geometry. There is inevitably 1 out of 10 people who tell me their story about how they were so good at algebra, but then they came to geometry and it was just so hard and they don't know why. Why was it so hard? And I'm going to give you the answer to that question so none of us fall into this trap. Geometry is an anachronistic class. It is an anachronistic class. Do you know what the word anachronism means? It means out of time. Chronos means time, ana means against. Anachronism means out against time. Geometry is an anachronistic class. If you understand that it doesn't seem to fit the normal course of progression, but seems different, if you understand why, then this class will make a ton of sense to you, otherwise it won't. The only way to understand why it's a historical anachronism is to understand the history of geometry, the history of mathematics, which is why I've created the wall behind me, and I'm gonna walk you through it now. You have to understand the geometry. In fact, you're gonna write a paper on the history of mathematics, history of geometry in this class, and you're gonna be able to speak about all this stuff fluently by the end of the year. So let's get to it. Today is a class on the history of mathematics. Let's go. All right, you'll probably notice up at the top, we have Jesus Christ, who is the Lord of mathematics. So my first question to you is, do you think math is discovered or is math created? What do you think? Well, when it comes to man, math is discovered, not created. How can I prove that to you? Well, the evidence is clear. Let's look over here. Every major civilization in the ancient world, these are Egyptians, these are Babylonians, I can certainly include many other civilizations from the ancient world, they all had robust geometry, the kind of geometry you're going to learn in geometry class. They all discovered it. And guess what? They all discovered exactly the same stuff. How is that even possible unless man is discovering geometry? Second question. If man's discovering geometry, did God create geometry? What do you think, yes or no? Did God create geometry? The answer is going to surprise you. I mean, you would think God created geometry, but I'm going to make some statements here and you see what you think. 1, geometry is not God. God is not geometry. 2, God doesn't learn anything. You would agree with that. So if God doesn't learn anything, did he ever learn geometry? No? All right. So then where has geometry eternally existed? In the mind of God. Geometry is not God. God doesn't learn anything. Therefore, geometry has always existed eternally in ontological time, before chronological time, in the mind of God. So did God create the geometry? Or did God always know the geometry? That's a deep thought, isn't it? So geometry has always existed in the mind of God, and yet man is discovering it. So how in the world does man discover geometry? Does God beam it into our heads? No. When God created, when he spoke creation into existence, he used mathematics. He imbued it into his creation. It's throughout the created order, and it's discoverable to you and me because God made us in his image with a rational nature that can discern geometry. So if you just go out into the universe, and I don't even have to teach you this geometry class. I don't need to give you a textbook. I could say for the next year, this would be an awesome project. Just go out and discover as much geometry as you can, and you would immediately crash into triangles and cubes, and you begin to discover patterns, and you could write those patterns down. And before you knew it, you would have discovered all the same geometry everybody else discovers. Look, I'm telling you, God has given you immense gifts that you may be unaware of to discern through general revelation, that is created order, what has been in his mind eternally. Come over with here to the beginning of the timeline. Okay. This right here is 1550 BC. So approximately how many years before today? To the nearest 100. About, well, let's see. There's 2,000 years between Christ and us, and another 1,550 years. All right, so we're talking about 3,500, 3,600 years ago. In ancient Egypt, I want you to look at this thing. It's called the Rhind Papyrus. I don't know if you can see it on it, but it's a detailed geometry textbook. Look at that thing. It's probably more complex than what you have in your textbook. How did the ancient Egyptians know all this? Because they discerned it by observing the created universe, in which God imbued geometry, and it's obvious, it's fingerprinted, it's sort of everywhere if you just look. Not just the Egyptians. Look back here. Can you see that? That's written in Babylonian cuneiform. I printed it on my 3D printer in the back of the room. It is a list of Pythagorean triples, which are integer solutions to the Pythagorean theorem. Lists of them. The ancient Babylonians had advanced geometry. The ancient Egyptians had advanced geometry. Every major civilization in the ancient world had advanced geometry, and they all had the same geometry because they discovered it. I mean, if you're wondering how advanced we're talking about, first of all, you can see this thing looks just like your textbook. But two, this civilization built pyramids and this civilization built ziggurats. You cannot do that without advanced geometry, period. All right, so God eternally knows geometry from ontological time. He imbues his creation with mathematics. He uses mathematics in the created order. We discover it, we write it down. The whole world seems to know geometry and is using it on a daily basis. Great. This is, by the way, 3,800 years ago, 3,800 years ago. Then we come up, something astonishing happens in this time period. You probably recognize these pictures as being the ancient Greeks. The ancient world's a little bit later, but here's the ancient Greek world. I've got busts up here of Pythagoras, then we have Socrates and Plato and Aristotle and Euclid. All right. Something happens remarkably in the ancient Greek world that happens nowhere else in the world. Here's what it is. This guy, Thales, who's a philosopher and a mathematician, is the first guy to say enough is enough. We all have geometry, all the major civilizations, we're all learning it, using it day by day, but no one has ever proved that is true in every circumstance. We think it works because it seems to work all the time, we all have the same geometry, but no one has ever proved it to be true from the most basic principles. So he sat down to prove geometry. And we know that he proved at least 5 different geometric theorems, including the one that bears his name, which is Thales' theorem. Okay, it would have died potentially with Thales, but he has a student named Pythagoras. I'm sure you've heard of Pythagoras because you've heard of the Pythagorean theorem, one of the 5 great theorems in all of human history. The only easy one, by the way. Pythagoras is not famous because of the Pythagorean theorem. What's the Pythagorean theorem? You know, a squared plus b squared equals c squared. What type of shape does it apply to? Right triangles. It's named after him, but not because he discovers the Pythagorean theorem. Remember, he told you this is full of Pythagorean triples. You can't build pyramids and ziggurats without the Pythagorean theorem. That's old hat. No, what makes Pythagorean, why is Pythagorean theorem named after him? Because he was the first person to discover a proof of the Pythagorean theorem. Remember, Thales, his teacher, started proving theorems. Pythagoras proved the Pythagorean theorem. But that's not why he's important. You're going to find out why Pythagoras is important right now. Here it is. He started a math cult. You've heard of cults like Scientology, right? Strange, weird practices and philosophies. Well, he started his own math cult. And this was no joke. This cult was very powerful in the ancient world for hundreds of years. It had its own religion. But here's what the math cult did. You had to be a part of the aristocracy, so you had to be rich. You had to be smart, and you had to be willing to devote your life to mathematics. They basically thought they could get to the divine through mathematics. They took it very seriously. So if you joined the cult, what'd you do all day? You worked on mathematical proofs. You were taking all this geometry that the ancient world knew and some number theory that the ancient world knew, and you were working on proofs, proving all this math. It's not easy to do proofs. It takes a lot of thought. That's what the Pythagoreans would do for hundreds of years. In fact, their cult would resurface throughout the generations. So some people were even Pythagoreans after the time of Christ. Interestingly, there is a document from the early Christian period that's not Christian writing, it's satirical, and it names three great philosophers, and one of them is Christ, but another one is Pythagoras. They're actually mentioned together. That's interesting. Can I tell you some crazy stuff about Pythagoras' cult? Well, the first thing I would tell you is one of their dogmas was that every number in the universe had to be a rational number. Now you remember rational numbers are numbers that can be expressed as a quotient of integers. So think of a fraction where you have an integer on the top and an integer on the bottom. He thought every number should be able to express rationally if you just figure it out. Well, his friend Hypasus discovered irrational numbers, and that was anathema. You know what anathema? If you were a Christian, you would say Jesus Christ is not Lord. That's anathema. Very blasphemous kind of stuff. Well, this is Hippasus Metapontinus Pythagoricus, or Hypasus from the city of Metapontin, who was a Pythagorean. He was Pythagoras' friend. He was a Pythagorean. He discovered the existence of an irrational number. He proved the existence of the square roots of 2. And this was shocking. So much so that Pythagoras took him on a sailing trip on the Mediterranean. And when our good friend Hypasus turned around, he stabbed him, he threw him overboard, drowned him, and that was the end of Hypasus. Now, we do have his proof, so it endured despite what happened to him. Another crazy thing about with this Pythagorean cult. Okay, so here's the story of the death of Pythagoras. You ever heard the story of the death of Pythagoras? It's a good one. Pythagoras thought that beings could be reincarnated humans. So he didn't eat beans because he didn't want to eat people, right? He didn't want to eat their souls. His cult was aristocracy, right? And sometimes in ancient cities, you'd have tension between the rich and the poor, right? Pretty extreme stuff. So sometimes the aristocracy in favor, sometimes the working class would be more in favor. And that would swing, and sometimes they drive each other out. Well, sometimes Pythagorean cults got driven out of cities because it was the rise of the plebeians, right? To borrow a much later Roman term, the plebeians versus the patricians. Well, as the story goes, Pythagoras was fleeing a particular city, and he was being chased by some of the lower class folks. He was going to escape to the Mediterranean, but he came across a bean field, and he refused to cross the bean field and trample those poor souls. So instead he turned around and allowed himself to be murdered by the crowd. Okay, so here's a question for you. What do you think happened to Pythagoras after he died? Heaven or hell? I'll leave that up to you to think about. Let's move on, shall we? But first, tell me why Pythagoras is important. Because he started a math cult that did proofs for hundreds of years and proved virtually all of known geometry. All right. Well, our next guy, the next Greek, is named Euclid, and he is the most important man perhaps on this wall. Perhaps the greatest mathematician on this wall, at least the second greatest mathematician on this wall. His name is Euclid, and he's called the father of geometry. I don't get it. Geometry has been discovered by all the civilizations. Pythagorean cult, all they're doing is proving geometry. So how does Euclid get the term father of geometry? Here's how. He takes all the knowledge of the Pythagoreans and he writes it all down. I mean, they were a secret society. He writes it all down and he publishes a book, definitely the most important book on this wall. It's called Euclid's Elements. It's a 13-volume book in which he proves all known geometry from some basic notions. His book, Euclid's Elements, starts with some basic postulates or axioms, self-evident truths, things that you and I could all agree upon are obviously true, no proof needed, such basic things. And then he uses deductive logic, irrefutable logic, to prove 465 theorems of geometry and some number theory, basically all the mathematics known of his time. Same math we have today, same stuff we learn as geometry or number theory. He wrote it all down in this book, Euclid's The Elements. All right, now I want to talk to you how important this book is. What is the most, hear my words specifically, what's the most important book in human history? How about this way? What's the most published book in human history? You know it's the Bible, no question about it, especially in the West. But it's the Bible. Hear my words specifically, what is the second most republished book in all of human history? No, republished, new volumes, new versions of the same book, reproduced for generation after generation after generation. What's the second most republished book in human history? And it's maybe not what you think. It's Euclid's The Elements. That math textbook is considered the greatest math textbook ever written. And for 2,300 years, you'll notice he wrote it in 300 BC, for 2,300 years, it's been considered the most important math textbook of all time. In fact, if you were an honor student, if you were an educated person, at any point from the year 300 BC until about the time of Descartes, who's in around 1623, for that 1900-year period, pretty much the only textbook anyone learned from was Euclid's The Elements. Were there other textbooks? Yes. Did people study other textbooks? Yes. But that's the textbook that everyone went to, just like everybody wanted to learn about God went to the Bible. Interesting. We're a classical school, aren't we? Okay, then we study the great works. Can you imagine learning the Bible because someone just told you about the Bible? Right? Never touch the scriptures, never open them for yourselves, never read John 3:16 and 17 for yourself. You just, whatever people told you about the Bible. That's crazy, right? It's the same thing here. You have a math textbook for this class, don't you? It's called Geometry by Glencoe. It's a consortium of authors. These guys. It's a decent textbook. You'll keep a copy at home. I have desk copies here, and you'll certainly be doing homework problems to this and doing reading out of this. And this tells you about geometry. But what geometry? The geometry that was written down in Euclid's The Elements. But just like we wouldn't just settle for hearing about the Bible, we read the Bible for ourselves, you're also going to read Euclid's Elements for yourselves. Now, you don't have to buy a copy of that. You can if you want, but I'll be making photocopies. It's in the public domain. The book's been around for thousands of years. And we will work through proofs from Euclid's The Elements, and you will become very educated on what, for most of human history, was the second most read book after the Bible. Okay. So the ancient Greeks are important because of proofs and because they wrote down all the proofs Euclid did. Shall we move on? The way my timeline works up here, some people like birth dates and death dates. I think they're too much to remember. So what I tend to do is choose the date right in the middle of their life and talk about that. So when you see Pythagoras at 533 BC, it's because it was the midpoint of his life. So you remember one date. It's easier that way. It's probably the prime of their lives anyway. Okay, except for one person who gets birth date, and that's the Lord of mathematics himself, Jesus Christ. Why did I put 1 AD? Because his birth splits the calendar. You probably have heard of AD and BC, right? What does AD stand for? Anno Domini. That's how you want to pronounce it. You want to use church Latin, you want to use classical Latin. It means the year of our Lord. You probably have heard stuff like, oh, the 1500s, the year of our Lord, I was sailing across the ocean. That's from the time of the birth of Christ. It splits the calendar. So he gets 1 AD, everybody else midpoint of their lives. All right, let's keep going here. Who is this guy? All right, I'm gonna pull down his book for you here. Whoops. All right. The guy behind me. Here's his book. All right. Now he has a nice long name because it's a Muslim name, but at the bottom is the name you got to remember, Al-Khwarizmi. Okay, Al-Khwarizmi. And he wrote this book, the compendious book of mathematical calculations. But I have left for you the title in Arabic. Why? Would you read the first line of the title of his book? Sound it out. What does it sound like to you? Algebra, algebra, algebra. What's it sound like to you? Algebra. Guess who's the first person to discover algebra? Al-Khwarizmi. What are you saying, Mr. Cartenuto? Are you saying that we really didn't have what we consider modern algebra until the year 815 AD? Yeah, no one had discovered it before that. What type of math did everyone do before 815 AD? Geometry and some number theory. That's what everybody discovered. Well, this guy discovers algebra. That isn't to say there wasn't some kinds of proto-algebra along the way, but okay. Before 815 AD, what math do we have? Geometry. What two maths do we have in 815 AD? Geometry and algebra. Do you remember the two definitions? Remind me, what was the definition of geometry? The math of shapes. And what was our working definition for our class? Would be a good working definition, not perfect. For algebra? Algebra is the math of equations with variables. You need both components. All right, so we have these two maths, but here's the thing. They didn't talk. No one had a way to translate between these two languages. Look, if I say I speak French, or I say je parle français, or I say hablo français, right? I'm saying the same thing in three languages. Clearly the idea is the same. But no one had a way of these two languages, geometry and algebra, speaking. If you're an algebraicist, or if you were a geometer, even if you were both, you still didn't know how to make the two talk. There was no Rosetta Stone. Do you know what the Rosetta Stone is? Yeah, some of you will know what the Rosetta Stone is. It exists in the British Museum. It's a big monument with inscriptions in three languages. Do you know the three languages? We got hieroglyphics, it's an Egyptian language, hieratic, it's an Egyptian language, and ancient Greek. Now here's the thing, you know about Egypt, you know about the Egyptian hieroglyphics, everybody knows about that in modern era. But Egypt was kind of ancient Egypt was kind of lost to history for a couple thousand years. Doesn't mean it wasn't in the historical textbooks. We have Herodotus as the histories. It's in the Bible. It's just that the cities and the monuments got buried. And then the British started unburying them, a century ago and more than that. And so we started discovering these pyramids and these monuments in ancient cities, and all of a sudden we encountered Egyptian hieroglyphics, and we had no idea what the stuff said because it hadn't been spoken for thousands of years. And no one knew what it said until the Rosetta Stone was discovered. And it had these three languages, the two Egyptian languages and ancient Greek. And we continued to have ancient Greek because in the West, most of our historical documents come from ancient Greece, right? Plato, Aristotle, these are all Greek thinkers. We had that. Plus, the Bible's written in Koine Greek, so we maintained our knowledge of Greek throughout. That was never an issue, right? Okay, So the Rosetta Stone allowed us to translate between Egyptian and Greek and learn Egyptian. Geometry and algebra could not talk in 815 AD. It wasn't until this man that we finally had the Rosetta Stone that allowed us to have geometry and algebra finally translating between each other. So who is this guy? He's a famous mathematician, obviously, and also a famous philosopher, as many of these guys are. He's the philosopher who said, I think, therefore I am. Who is he? His name is French guy, René Descartes. René Descartes. All right. Here. I'll write down his name for you, and it's going to help us. René Descartes. Okay, if you don't speak French, it looks like Descartes. It's not, it's Descartes. And he wrote the book La Géométrie, just means the geometry in French. Okay, he discovers the Rosetta Stone that allows us to translate between geometry and algebra. And you know this Rosetta Stone already. You've used it hundreds of times. Can you think of what it is? It's right here. I don't know if you can see this or not, but it's right here. What is that thing called? Here, let me highlight it for you what I'm looking at. What is this thing called? It's called the coordinate plane. What type of coordinate plane? It's got a name. It's called the Cartesian coordinate plane. Cartesian coordinate plane. René Descartes. That's where you get the name Cartesian coordinate plane. Let me show you. Can you see it? René Descartes, Cartesian coordinate plane. And that is what allows us to translate. Here, I'll prove to you, you already know how to translate between geometry and algebra, and that the way we've always done it is the Cartesian coordinate plane. We haven't changed it since he discovered it, around 1600. Here you go. Let's say I were to give you this equation, y equals 3x plus 5. Okay, you admit this is algebra. It's an equation with variables, to use our definition. Could you translate it into geometry, which is the math of shapes? Of course you can. Can you see there's a slope of 3 and a vertical intercept, a y-intercept of 5? Okay, we got a y-intercept of 5. We go up 3 over 1. And here we go. I will kind of freehand it here, but let me do at least a decent job. Do you see this line right here that I created? That graph, that's a shape. We've very quickly translated from algebra to geometry, and I could go the other way. Pretty awesome, huh? So much so that we had to give names to things. When you are doing ancient Greek geometry, the geometry of Euclid, when you're doing proofs, what you do in a geometry class, it's pretty standard geometry class to do proofs, you're doing what we call classical geometry. When you're doing the geometry where you're translating continually between algebra and geometry, that's called analytical geometry. Analytical geometry. We're going to do both in this class. You will be fluent at translating between 3 languages. So much of math is translation. You're going to translate between a language you know, English, which we call verbal in math, geometry, and algebra. You will translate fluently between the 3, and then you most often actually solve the problem, solve the equation through algebra. Sometimes you'll solve it using geometry. You could easily solve it using verbal. All right. The second thing we'll be doing is a lot of proofs, just like Euclid do, where we prove geometry. In fact, in this class, you'll learn how to prove geometry and number theory. You're not going to do that in any other class in your high school career. You'll have some proofs in pre-calculus, trigonometric proofs, but outside of that, you just don't see them. That's why this class can feel so weird. But again, it's an anachronistic class, a class out of time. But it's so foundational. Hopefully, as you understand the history, you'll understand what we're doing in this class. All right, a couple more people on the board, and then we'll call it a day. This guy, who is he? Sir Isaac Newton. He wrote the second most important book up here, which is called Principia Mathematica. All right. 1685, Sir Isaac Newton. Why is this guy famous? Now I know you're thinking, gravity. He's the guy who had an apple, dropped the apple and said, oh ho, the earth seems to be attracting everything to it. Oh, and the planets in the solar system, they seem to be revolving around the sun, so the sun's attracting the planets and vice versa. Every object has a certain mass and a certain distance from the object and is attracting it with a force called gravity. Okay? I know you know that. I know you probably know about the laws of motion. Famously he discovers the laws of motion. But let's zoom out from that. You're talking about the tips of the diamonds. That's two major things he discovers from a much broader perspective, much broader. Do you know what they are? Physics and calculus. Here's what happened. You've all been through a pandemic, haven't you? COVID-19. For the adults, it was very traumatic. We all had to wear masks. We were all very grumpy. We had to stay home. We didn't know what was going to happen. Oh. Some of you at home, maybe you were homeschooled. It was a great time for you. But for the majority of students, it was a time where your education might have fallen off because you had to do hybrid learning and with lockdowns. Not the most productive time in history. Do you know that Isaac Newton also went through a pandemic? It was the Black Plague. And his neighbors were dropping dead. So anyone with means like Isaac Newton went on lockdown and stayed in their homes so that they didn't get sick and die. Well, here's what he did for the few months he was on lockdown. He discovered of all of what we call now physics and the math that describes that physics that we all call calculus. That's pretty incredible. Of all the people up here, mathematicians and scientists, the greatest one, most mathematicians and scientists will agree, is Isaac Newton, because wow, does anyone do that? I mean, during the pandemic, during the SARS pandemic, did you discover teleportation? No? Okay, well, he discovers all of physics and all of calculus. Pretty incredible stuff. One more person we want to talk about today, you'll recognize him. Primarily, he's a scientist, but also a mathematician. His name is Albert Einstein. Now, do you remember what he discovered? You may say E equals mc squared. You'd be correct, but again, that's just the tip of the diamond. We've got to step back and say, what is it he actually discovered? Do you remember his theory? It's got a name. It starts with the letter R. It's relativity. Albert Einstein discovers relativity. So let's look at relativity and say what's the most important idea in relativity. And here it is, general relativity. Mr. Einstein will tell us that gravity is not actually a force like Newton said, but it's an illusion created by the distortion of space-time, all right? This is gonna be really hard for you to understand today, but you'll be hearing this throughout the semester, so you will understand it and be able to fluently speak about relativity by the end of this year, no problem. All right, I want you to imagine that space, three-dimensional space, is divided into a bunch of planes going this way, a bunch of planes going this way, and the bookshelves, a bunch of planes going this way. So it's a big cubular grid. And if I were to take a stone in space and throw it, it would continue in a straight line because all of these three dimensions, these planar dimensions, are of equal strength and equal value. That's how Newton thought the whole universe existed, that it was what we call flat geometry. Not flat as in two dimensions, but three-dimensional flat. Three-dimensional flat. That kind of stuff. Euclidean. Here's what Newton wasn't wrong, he was just incomplete, because what he didn't realize was that around large bodies in space, space actually gets distorted into a negative curvature, a hyperbolic type of geometry. So around planets, space actually looks like this. If here's the planet, sorry, I got a busted shoulder. If here's the planet, space is looking like this, negative curvature all around it. Black holes, even more pronounced, suns, stars, very pronounced, negative curvature geometry. And here's the thing you need to know. We don't actually stay still and have to move. We're actually all in motion all the time. It's called free fall. And it would actually be very odd for us to stop moving. I know you don't perceive that, but that's how it actually is in this universe. And we tend to move along geodesics, shortest paths. You kind of consider them paths of least resistance in that sense, but the shortest paths. So I want you to imagine it's a planet, and space, which is normally just flat Euclidean in 3 dimensions, not 2, right, gets distorted so that you have negative curvature space, let's say this portion of space. Okay, you have an object come flying along in space. It's going to follow the geodesic, meaning that kind of invisible shape of space. Well, it's going to start following that same curvature. You see that? And it's going to then hit the planet. What? But that looked like gravity sucked it in. It's not that gravity sucked it in, it's that large object of space distort space-time. And so it goes beyond just space, it goes to time as well. Time is different on planet Earth than it is even up where the satellites are. This is a proven fact. If we, Elon Musk is always sending satellites into space. You know that, the Starlink satellites. Well, we couldn't possibly communicate with them without the theory of relativity, at least not correctly, because they're actually traveling at a different pace of time than we are down here on Earth. Time slows down here on Earth because of the distortion in space-time created by Earth itself. Okay, pop quiz. Let's see how you do. Who created math? Nobody. It's always existed in the mind of God. Who discovers math? Humans. How? Because God imbued it in creation, we can discover it with the rational powers of our mind that God gave us, being made in His image. Which civilizations from the ancient world discovered geometry? Every major civilization from the ancient world, including the Egyptians and the Babylonians. That's called Plimpton 322. This is called the Rind Papyrus. Remember these. What did the ancient Greeks do that no one had done before? They set out to prove known geometry, starting with basic principles and then using logic to prove known geometry. Thales was the first, 585 BC. His student Pythagoras started a math cult called the Pythagoreans, and all they did all day long was write math proofs secretly. Euclid, he's called Father of Geometry. Why? Because he wrote it all down in the most important math book of all time called Euclid's Elements. In that, he starts with basic truths that we all agree upon called postulates or axioms, and he proves 465 known theorems from geometry and some number theory. Okay? Who's this guy? Al-Khwarizmi. What did he discover? Algebra. Remember his book name? Was Algebra. Okay? Geometry and algebra can't talk until this guy. Who's this guy? René Descartes. And what did he come up with? That was the Rosetta Stone. The Cartesian coordinate plane, which allows us to translate between geometry and algebra. Who is this guy? Isaac Newton. What did he discover during a pandemic? Physics and calculus. Who's this guy? Einstein. What does he discover? What we call modern physics, the theory of relativity, wherein he discovers that gravity actually isn't a force, but the distortion of space-time caused by large objects. All right, and pop quiz, what was geometry? Give you the definition again. The math of shapes. And algebra, the math of equations with variables. Again, this is just a good working definition for this class. Certainly we find stuff that falls outside that realm, but this is going to help you a lot. All right, I am looking forward to you getting it. getting history, getting mathematics within its historical context, learning to translate between languages and solve problems, learning to prove mathematics. If you stick with this and work hard, your mind is going to expand, your brain's going to get stronger, and you're going to be a better thinker than you ever have been in your life. And I know you can do it because you're made in God's image. Thank you. Have a good day.